rationals. A rational number is a ratio of integers a to b, so every single time you get a fraction or even just integers, you can put them over 1 and they would be a rational number, right? Rational expressions, however, are like fractions, so they follow all the same fraction rules, but they have polynomials embedded in them. It's a ratio of polynomials. So we're going to look at this example here. What happens in each of the following expressions when x equals 3? So we're going to plug in 3 and see what happens. So here we're going to get 3 minus 7 over 3 minus 3, which is negative 4 over 0. Put negative 4 over 0 in your calculator. Negative 4 divided by 0. Error. You can't divide by 0. So this is not possible. Okay, let's put a 3 into this one. X equals 3. So x minus 7, oops. 3 minus 7 over 3 squared minus 9. So it's going to be negative 4 over 0. So not possible. Put in a 3 in this one. 3 minus 7 over 3 squared minus 4 times 3 plus 3 is going to be negative 4 over 12 minus 12, so 0. So not possible. So there's this thing called non-permissible values, which we're going to talk about more, so exactly what it is and definition on the next page. But there's these reasons why we have non-permissible values whenever we have rational numbers or rational expressions. Because, for example, in these ones here, if you put a 3 in the bottom, you're going to get 0 in the denominator, and it's not possible. So you always have to state what x can't be, because if it was that value, your denominator would be 0. They're called non-permissible values. So we're going to look at this one, these ones down here. What value or values cannot be used for x in each of the following expressions, so that if you did use it, you would get a 0 in the denominator. The numerator doesn't matter. You can go 0 divided by 3 in your calculator, and it'll tell you it's 0. So you can have a 0 in the numerator, the top, you just can't have it in the denominator. So what can't x be that would cause the denominator to be 0? Nope. 0. So what we can do is we can go 2x can't equal 0, because it's true, 2x can't equal 0. Divide by the 2, and x can't equal 0. So that would be our non-permissible value for this one. Or you can look and say, hey, what value could I fill in there that would cause this bottom to be 0, the denominator? So for 2, what could x not be that would force the denominator to be 0? 7. If I went 7 minus 7, I get 0. If that's not blatantly obvious to you, because for some people it's hard to see that, what you can do is just take that value and say, hey, x minus 7 can't equal 0. It's not allowed, right? If it equaled 0, then my denominator would be 0, and it can't be. And then add your 7 over. So x can't equal 7. So if you can't see that it would be 7 minus 7, which would be 0, that's fine. Just do the math, okay? It'll do it for you. The next one, I'm going to end up with 2 non-permissible values, because if this bracket here became 0 somehow, 0 times anything would be 0, right? If this bracket here became 0 somehow, 0 times anything would be 0. So we have to actually do both brackets separately. So we go x minus 3 can't equal 0. So if it can't equal 0, then x can't equal 3. And we know we're right because we can take the 3, fill it back in. 3 minus 3 would be 0. This bracket would be 0 times something. It would be 0. And the next one would be 2x plus 1 can't equal 0. Subtract the 1. This one isn't as obvious as the other ones, right? It's a little bit more complicated. So I do the math for this one. Subtract the 1, and we get 2x can't equal negative 1, and then divide by 2. X can't equal negative 1/2. And then you can check your work. Go back. 2 times negative 1/2 is negative 1. Negative 1 plus 1, 0. So I know I'm right. And then you usually write them together. X can't equal, and usually they write from lowest to highest, but it doesn't matter if you put it in the other order. Negative 1/2 and 3. Okay? So with all rational expressions, whenever you have a letter or a variable in the denominator, you have to state non-permissible values. So let's flip over. So it says, write a rule that explains how to determine any values that a variable cannot be for an algebraic fraction. So basically, you set any factor in the denominator not equal to 0 and solve for the variable. So that's why with the last question we got 2 non-permissible values, because we had 2 factors. Whenever you use a rational expression, you must identify any values that must be excluded or are considered non-permissible values. Non-permissible values are all the values that make the denominator 0. The next example says determine the non-permissible values for the rational expression. So we have to determine the non-permissible values. That's all it asked us to do. Didn't ask us to do anything else other than tell us what the non-permissible values are. This 3 and B and C are not like actually attached by any plus or minus signs, right? They're all multiplied. So if they're all multiplied, you can put them in their own brackets just like those 2 factors of the last question. So 4A over 3 times A, or sorry, times B times C. 3 times B times C. So they're all in their own brackets when they're multiplied, right? Then anything in its own bracket you can set not equal to 0. So we'd have NPVs here so that I know what, so when I'm marking it, I can find where the heck you wrote the NPVs and I'm not trying to decipher through your work. And then I can say 3 can't equal 0. Do I actually have to state that? Can 3 ever be 0? No, that's not going to cause the problem. So that's not actually an NPV. So we only have to state non-permissible values of the letters, right? So then we'd have B can't equal 0 and C can't equal 0. And then we're done. Because you don't have to go solve any further, right? If it was 2B can't equal 0, then we'd have to divide by the 2. But it's just B and C by themselves. You try part B and C. See if you can do them. Hint on C, it's a difference of squares in the denominator. You're going to have to factor it first. Okay, for part B, we have x plus 2 and x minus 3. So you can say, hey, it can't be negative 2 or 3. Or you can go x plus 2, non-permissible values. X plus 2 can't equal 0. Subtract 2. X can't equal negative 2. Or x minus 3 can't equal 0. Add 3. X can't equal 3. And then you put them together. X can't equal negative 2 or 3. Now C, like I said, factor it if you have to. This one you can make a difference of squares. So on the top you'd have 2y squared. And on the bottom, square root of y squared is y. Square root of 4 is 2. And then it has a minus sign in it. So that's a good thing. That means it's a difference of squares. If it had a plus sign, you couldn't do this, because it wouldn't be a difference of squares. So you get 2 brackets. You get the y in the front, the 2 at the back, and then opposite signs, plus or minus 2. So you'd have y plus 2 can't equal 0. Y can't equal negative 2. Y minus 2 can't equal 0. Y can't equal 2. So we can put them together and we can say y can't equal positive or negative 2. Now, if you forgot to do a difference of squares with this one, you could actually solve it out normally. So you could go y squared minus 4 can't equal 0. You can only do this as a binomial difference of squares. If it's a binomial something else, you'd have to separate them and GCF them first. If it's a trinomial, you can't. So you move the 4 over, y squared equals 4. And then when you square root, you have to remember to take the positive negative. So it'd be y equals plus or minus the square root of 4, which is 2. So you get the same answer, but it only works for difference of squares. So my hint to you would be to always factor first and to put away your phones. Those are my 2 hints. Okay. Example, simplify the rational expression and state non-permissible values. So if we have to simplify and then state non-permissible values, the very first thing you want to do is look at this and say, hey, it's 3x minus 6. They're attached together. Put brackets around them. Anything that's attached by plus or minus signs gets put in its own bracket. So technically here I have 3x minus 6 in a bracket. And then these are all attached by plus or minus signs. So I have 2x squared plus x minus 10 in a bracket. The only way you can cancel off rationals is if everything in brackets in either side, the top or the bottom, matches exactly in every way. So the only way I can get rid of 3x minus 6 is if I have a replica on the bottom. And the only way I can get rid of 2x squared plus x minus 10 is if I have a replica of a twin of it on the top. Okay? So right now I'm not getting rid of anything because nothing matches. So what I have to do, GCF or factor always when you're simplifying rationals. GCF or factor the top and the bottom. So on the top, what can I take out? A 3. When it's 2 terms or a binomial, all you can do is GCF or difference of squares. It's not a difference of squares, so the only thing I have left to try is GCF. Always try and take out a greatest common factor first. So I can take a 3 out, and I'm left with x minus 2. On the bottom, it's a difference of squares. So I go off to the side and I do it. Don't do it down here. It just gets messy and you have ugly work. Go off to the side, factor it, and bring your 2 factors back. Okay? So 2x squared plus x minus 10. So I say what times what equals negative 20. 2 times negative 10. Negative 20. What plus what equals a positive 1. What do you think it's going to be? What multiplies to give me negative 20 and adds to give me a positive 1? Yeah. 5 and negative 4. And then always go back and check and make sure you actually got the right numbers because sometimes people's signs are wrong. 5 times negative 4 is negative 20. 5 plus negative 4 is 1, so I know I'm right. Now, I can't go right off and go to brackets right away. Why can't I? Because this first number is not a 1. If the first number, the leading coefficient, is a 1, then I can go to brackets right away, but it's not. It's a 2. So remember, you have to do decomposition. So you have to replace this middle term with these 2. Because 1x is the same as 5x minus 4x. That's also 1x, right? So all I'm doing is trying to find 2 terms that I can replace that 1x with so that I can do grouping. So you rewrite the 2x squared, because I'm not doing anything. Then this 1x I'm going to replace with 5x minus 4x, because what's 5x minus 4x? 1x, right? That's all I'm doing. So I'm going plus 5x minus 4x. Does it matter? Does it have to be 5x first and negative 4x second? No. Could I have them the other way? Yes, and most people want them the other way because they think that the 2 and the 4 go better together. It doesn't matter which one you put. Like, don't spend an hour trying to figure out which one will be better. If just put them down and it works out in the end anyways. But you can pick which one goes better. The 4 would probably go better with the 2, and the 5 would probably go better with the 10. But I'm writing them this way to prove to you that it doesn't matter. Okay? So we literally just replaced that middle term with 5x minus 4x because that is 1x, right? That's all we did. Then we're going to group. Group the first 2, group the back 2. What can I take out of the first 2? I can take out an x. And then I'm left with 2x plus 5. Now the second bracket, I have to be left with 2x plus 5. The brackets need to match, right? That's ultimate goal in decomp. So I can take out a negative 2 because I need it to be a positive 2x plus 5. Then the reason why we get a 2x plus 5 in our factoring is, hey, these are 2 terms. They're connected with a minus sign, right? What's common to both of them if I did GCF? A 2x plus 5, correct? So I would take out a 2x plus 5 out of these 2 terms that I drew lines underneath, and then I'd be left with x minus 2. That is why you get what you get at the end. What other way? then it would just end up being x minus 2 in the brackets, and 2x here and plus 5 here. If you did it the other way, these would be this way, right? I'd take a 2x out front, and I'd be left with x minus 2. And then these would be flipped, so I'd take out a plus 5, and then I'd be left with x minus 2. So these just, the factors basically flip if you do it the other way around, but you still get the same factors, right? So then I go over here and I write them down. 2x plus 5, x minus 2. And honestly, if I have two factors, if I have to factor the top and the bottom, I'll like label them as like 1 and like 2, and then go over here and label this as 2, so that I don't get them mixed up. Because you're going to be doing, sometimes in multiplication, you're doing this over this times this over this, and you might be factoring through 4 trinomials to multiply or divide. Keep in mind that if you're going into 30-2, this is a direct unit that's in 30-2. So if you're like, I'll just get through this and not really learn it, because I'm going into 30-2, not a unit that you want to even think that on, because it's the very first unit we do in 30-2, is rationals. Okay? All right. So I know people get excited because they see an x minus 2 here matching. So we know we're going to be able to cancel them, but we can't cancel until we state our non-permissible values. Because our non-permissible values are what x can't be, and you always have to state them before you cancel them off. Because if we cross these off, if I took that 2 and I filled it in here, what would I get? 0, right? Just like I did with that 3 that I did before. So I can't just cancel this off and not state an NPV. I always have to state my non-permissible values before I cancel. Always remember that. So I go off to the side and I write my non-permissible values, and I say 2x plus 5 can't equal 0. Move the 5 over, so 2x can't equal negative 5. And then divide by 2. So x can't equal negative 5 over 2 is one of them. And then I go x minus 2 can't equal 0. So x can't equal 2. And then to make Mrs. Lepp's life better when marking your test, and when you make it better and easier for me to mark, then I can give more part marks if you oopsie, I would go x can't equal negative 5 over 2, comma 2, bold it, even write NPVs beside it. If it's easier for me to find, it's easier for me to give you part marks, right? If I like have a piece of NPV over here and a piece of NPV over here, it's hard to mark. Okay, this 3 can be in its own brackets too, you guys, because it's being multiplied by something, right? Now we can only cross off what's the same. Do I have a 2x plus 5 up here at all? This is never going anywhere. This is staying for life. It does not have a twin up top. Do I have a 3, or even if I had like a 6 out front in its own brackets, then I could cross off a 3 out of both, right? I could do that, but I don't have that. So the only thing that can go is this x minus 2. And so I'm left with 3 over 2x plus 5. Done. Now, over here, I know this is not the actual case as to what this equation is, but say this equation ended up being like this, 3, 2x plus 6, let's say. It's not, but let's just bear with me here. I always say to put, let's just say it's 3 over x plus 6. Let's pretend it's that, okay? That's done, technically, correct? This would be in its own bracket. This would be in its own bracket. You can't go any further. Do you know how many people on the test do this? And write 1 over x plus 2? Okay? You can't do that. You will try and do that. Trust me. I've done this long enough that this is a common error. Just like in radicals, when you guys are supposed to stop here and you like keep going 4 more steps and I have to dock marks because you should have stopped at the correct answer like 4 before. Same thing here. Okay? So why I hazard you to put stuff in brackets, 3 would be in brackets, x plus 6 because they're attached by a plus sign would be in brackets, correct? Is there an x plus 6 on the top? No. Is there a 3 or any form of a 3 on the bottom, like a 6 or a 9 or a 12? No. Done. Don't try and go any further. The biggest error in rationals is people forgetting to factor or take out a GCF and crossing off way more than they ever should. Okay? Actually canceling way too much is an error in rationals. Okay, next page. So, you guys can go in partners for the next little bit, as long as you're working. This first part here, I want you to write down what the steps would be for simplifying. If you don't want to go in partners, that's fine. You can stay by yourself. As long as you're working, or else I won't let you stay in partners. So, in partners, come up with what you think the steps would be, and then we're going to go through them in like a minute. Okay, let's look through steps. So the first step was GCF or factor. Like you're going to have to GCF or factor the tops and the bottoms, right? The numerators and denominators. Two, put brackets around anything with plus signs. Put brackets around anything with plus or minus signs. Anything attached by plus or minus signs. Three, state NPVs. And four, I would say cancel any common factors and write what's left over. And I guess if you want to be more specific, you could write cancel any common factors in the numerator and denominator. Because it has to be in the numerator and denominator. If you have an x plus 2 on the bottom and another x plus 2 on the bottom, they're staying. You have to have like one twin that matches on the bottom and the top. Okay? So the next example, I would have to factor both the numerator and the denominator. So I'm going to label this number 1, and I'm going to label this one number 2, and I'm going to go off to the side and factor them both. So number 1, 2y squared plus y minus 10. And number 2 is y squared plus 3y minus 10. Now you guys, the more organized you stay, the better it's going to be for you. Because when we get to multiplying and dividing, and you're multiplying and dividing 4 different factoring things, and you're going to have to factor 4 trinomials, you're going to want to keep it organized. So, this one we're going to say, what times what equals negative 10? Oh, is it negative 10? No. So it's going to be, I'll do it here. What times what equals negative 20? Otherwise, we have to go 2 times negative 10. And what plus what equals 1? So positive 5 and negative 4. Now it's decomp because we have a 2 in front, right? We can't just write brackets. We can't just go y plus 5, y minus 4. If you're someone who does that, stop yourself. You can't do that. You will be wrong. This is a 2 in front. You can't just go to brackets if there's a 2 in front. If there's a 1 here, for sure. But a 2, you can't. So you're going to go 2y squared plus 5y minus 4y minus 10. Group them. You could have went minus 4y plus 5y. That's absolutely fine. In the first set of brackets, we can take out a y. And then we're left with 2y plus 5. In the second set of brackets, I needed 2y plus 5, so I take out a negative 2. And I'm left with 2y plus 5. So my factors are y minus 2 and 2y plus 5. This looks very familiar to the last question, if you haven't noticed. So on the top, number 1, I have this equals y minus 2 and 2y plus 5. Then I have to factor the denominator. What's the great thing about the denominator? It has a 1 in front. So since it has a 1 in front of my y squared, I can go straight to brackets. I don't have to do decomp. I'm going to have y, and then I'm going to have to figure out what goes behind. So I go what times what equals 1 times 10, so negative 10. And what plus what equals 3. Yeah, 5 and negative 2. And the great thing about this one is I can just go plus 5 minus 2. And the only reason why I can do that is because there's a plus 1 in front of that y squared. Okay? If there's not a plus 1 there, you have to do decomp. You have to do the replacing and the grouping and all that fun stuff. So on the bottom I have y minus 2, 2y, y plus 5. Now, it's going to be hard for you to not just go crossing them off right away, but you have to state non-permissible values. Okay? So you're going to have y minus 2 can't equal 0, so y can't equal 2. And then y plus 5 can't equal 0, or y can't equal negative 5. Normally I state them up here, but I don't have room. So the NPVs are going to be y can't equal negative 5 or 2. Now that I stated non-permissible values, I can cancel off the common terms. So these cancel, and I'm left with 2y plus 5 on the top and y plus 5 on the bottom. And I'm done. But what's the common error here? People cross this y plus 5 off with this one and leave me a 2 on the top. This is 2y plus 5. It's not going anywhere unless I have a 2y plus 5 on the bottom. This y plus 5 is going nowhere unless I have a y plus 5 on the top. I don't. I'm done. I can't make this any better. You can't just cross these off because they look similar. That happens all the time. Okay? This used to be in 10 pure when I first started teaching 10 years ago, and I'd mark the first quiz and I'd be like, oh, they all can do this. Then I'd mark the first quiz and I was like, oh my goodness. Like the answers were all like 2, 7, 3. It's rare that you even get like a 2 or a 7 or a 3. There's usually like at least an x plus 3 left somewhere in the question. So if all your answers are turning out into like nice whole numbers like 10 and 4, question, maybe I'm doing something wrong when I'm simplifying these. Maybe I'm going a little over crazy with my simplifying. Okay? We're going to do the next one together, and then I'm going to get you guys to work on the next 3, okay? This one here is a monomial over a monomial. Monomial means one term because there's no plus or minus signs, right? So anything that's in that's just multiplied, I told you can put it in its own brackets, right? So you're going to go 4 over 3 times pi times r cubed. And then 4 times pi times r squared. Keep in mind, you guys, pi is not a variable. Pi is 3.14159. It keeps on going. It's a non-terminating, non-repeating decimal. So if I'm going to state non-permissible values, I only have to state them for the r. And what can't r be? R squared can't be 0, technically, right? So what would that make r be in order for it to not be 0? 0 squared is the only thing that will make you 0. So r can't equal 0. Now, if this confuses you, this is just like r times r, and this is like r times r times r, right? Just like it was under the radicals. So this is 2 r's, and I can take 2 off of here, so I'm actually just left with 1. If that's confusing to you, you can write r times r times r on the top over r times nothing on the bottom, and then you'd have your pi, and you'd have your 4 over 3, and you'd have your 4, and this r cancels off 1, this one cancels off this one, and you're left with 1. You can do it that way. You can write them all out and cancel them off that way if that's easier for you. It's the same thing. One's just literally writing all the r's out. Now the pi's cancel. Then go 4 divided by 3 divided by 4 in your calculator. Or you can think of it this way, 4 over 3 divided by 4 over 1, technically, right? And when you multiply fractions, you have to flip, or divide fractions, you have to flip and multiply. So you actually get 4 over 3 times 1 over 4, which is 4 over 12, or 1/3. So you're actually left with, when you divide these out, you're left with 1 over 3 and an r still left on the top. Done. Try the next 3 out. The hint to this one here, guys, look at this one. It has an x cubed. You don't even know how to factor an x cubed. X cubed is polynomials, which is degree 3 polynomials, which is in grade 12. But each one of these has an x in it. Take an x out, and then trinomial factor it. Okay? So try these 3 out. The top right here, the x squared minus 1 is the difference of squares. So you square root the x squared, you get an x, and you square root the 1, and you get a 1. So then you get x plus 1, x minus 1 on the top. On the bottom, I'm going to go over here, x squared plus 3x plus 2. And I say what times what gets me 2, and what plus what gets me the middle term 3. Now it has a 1 in front of the x squared, so I can go right to factors. What is up with you? Mylan. So, brackets, put an x, and then we say 2 and 1, or 1 and 2. X plus 1, x plus 2, okay? And you can go right to x's because there's a 1 in front of the x squared. There's a 1 in front of the x squared. So you can go right to brackets. You don't have to do decomp. Yep. So we have x plus 1 can't equal 0. Shh. And x minus 1 can't equal 0. So x can't equal negative 1 and x can't equal 1. So x can't equal plus or minus 1. It's just from off the bottom, guys. If it was negative 1, this would become 0. If it's positive 1, this would become 0. Yeah. Ah, I don't know why. Ah. This one. This is x plus 2. These are my factors. I just didn't write them. I wrote the other ones. So this one would be x plus 2 can't equal 0. X can't equal negative 2. So x can't equal negative 1 or negative 2. Okay, what's common to the top and the bottom? What's common to the numerator and denominator? An x plus 1. And you're left with x minus 1 over x plus 2. All right, the bottom left, you can take a 2x out of the top. And then you're left behind with x squared minus 2x minus 15. And on the bottom, I can take a 4 out, and I'm left with x squared minus 5. X squared minus 5 is not a difference of squares. The square root of 5 is a decimal, okay? So if you square root both of them, they should be whole numbers. So x squared minus 5 stays x squared minus 5. It doesn't get anything better, all right? The 2 and the x can be in their own brackets because they're multiplied, and the 4 can be in its own brackets because it's multiplied. The other ones have to stay in brackets like they are because they're attached with minus signs. So I have to go off to the side and I have to factor this one. This one's going to stay the same. I can't do anything to it. So I'm going to go x squared minus 2x minus 15. I have a 1 in front, so I can go strictly right to brackets. And I say what times what equals 1 times negative 15, so negative 15. And what plus what equals negative 2. So negative 5 and positive 3. So I'm going to get x minus 5 and x plus 3. So this x squared minus 2x minus 15 gets replaced with those two factors. So I have 2 and x, and then this gets replaced with those, x minus 5, x plus 3. And then I have 4, x squared minus 5, bless you. Now before I try and cancel anything off, I have to state non-permissible values. So this x squared minus 5, I just take off the side and I say NPVs. X squared minus 5 can't equal 0. Move the 5 over. X squared can't equal 5. And then I square root it. When I take the square root of a number, I have to remember to put positive, negative in front of it. So x can't equal plus or minus root 5. That's it. That's my only NPV, because 4 isn't 0. And you don't state non-permissible values about the top, because it doesn't matter if the top equals 0. You can go 0 divided by any number, and it tells you it's 0. That's fine. You just can't divide by 0, so your denominator can't be 0. The only thing I can cancel off is I can take a 2 out of both of these. This is x squared minus 5. There is no x squared minus 5 on the top. There's an x minus 5, but it's not x squared minus 5. These are two different things. This would have to have an x, and it doesn't. So there's nothing else going except for this 2 and 4. 2 I can take a 1, and then the 4 divided by 2, I can take a 2. So I'm left with x times x minus 5 times x plus 3 over 2 times x squared minus 5. No. Yeah, after the next one. So you have x squared minus 81 on the top, which is a difference of squares, because when you take the square root of x squared, you get x. When you take the square root of 81, you get 9. So you're going to get x plus 9, x minus 9. The next thing I would suggest you do is if you have two terms just on the bottom like that and it's 9 minus x, I always write it so the x comes first. So I'm just going to rearrange that. Whatever sign is in front of it stays with it though. So this is a negative x, so I'm going to get negative x, and a positive 9, so I'm going to go plus 9. Now why I do that is I can see somewhat similarities in the numerator and the denominator. In the denominator, I have negative x plus 9. In the numerator, I have positive x minus 9. So I have the complete opposite. So if that's the case, I can take a negative 1 out of the denominator. So here I have x plus 9 on the top, x minus 9 on the top, and in the bottom, I can take a negative 1 out. If I take a negative 1 out, I'm left with positive x and minus 9. Look, they match. But if people don't usually write them x then the number, they usually don't spot that. They don't see that there's actually a chance that they're the same. So I was right, x then number. Now my non-permissible value is just going to be 9, because if it was 9, 9 minus 9 is 0. So x can't equal 9 is my non-permissible value. Once I have my non-permissible value down, I can cross off the common terms. So it equals x plus 9 over negative 1. Which is not incorrect to leave it like that, but it's not in its best form. So when you divide by negative 1, you literally just change the signs in everything above, and then the negative 1 can go away. So instead of writing it as x plus 9 over negative 1, I can write this as negative x minus 9, because you can move the negative 1 up and then distribute it through. So this is a better answer. We're going to flip ahead to the next page and do one example, the one in the middle. So what happens if I give you x's and y's, which isn't going to happen a lot, but what happens if it does? So let's factor 16x squared minus 9y squared. It's a difference of squares. 16x squared, if I square root it, is 4x. 9y squared, if I square root it, is 3y. So I'm actually left with 4x plus 3y, 4x minus 3y. Over, and the bottom, what can I take out in the denominator? 8x minus 6y. What can I take out of those two terms? A 2. I take a 2 out. I'm left with 4x minus 3y. Now, stating NPVs for these is a little bit crazier because you have x's and y's. So I'm going to go off to the side. I'm going to say 4x minus 3y can't equal 0. And then you pick one of the variables to solve for. If you And which one's better is the one that's the multiple choice answer on your test. Other than that, which one's better, it doesn't matter. You can solve for x or y. I'm going to choose to solve for x. So 4x, and then I'm going to add the 3y over. My non-PV. So 4x can't equal 3y. And then I want to get x by itself, so I'm going to divide by 4. So x can't equal 3 over 4y. So if it equaled 3 over 4y, it would cause me to have a 0 in my denominator. So these cancel now that I have non-permissible values. And some people want to take this 2 and 4 and cancel them. Can we do that? No. The 2 can only go away if I have something in monomial of some sort in the front that's like 2 or 4 or 6 or 8. I don't. 4x plus 3y is only going away if I have a 4x plus 3y in the denominator. And do I? No. So it's not going away ever. Okay? So I'm left with 4x plus 3y over 2. This is the last question, and then you're going to work on homework. Create a rational expression with the variable m. So our variable is going to be m in this case. That has non-permissible values of -1 and 2. So basically, m can't equal -1 or 2. So what type of rational expression would I have to do in order for those to be my non-permissible values? What would have to be in my denominator? What factors? Yeah. Yeah. So I'd have to have m plus 1 is one of my factors, and m minus 2 is one of my other factors. If you wrote them as x's, I wouldn't take it down, but it does say m, but it's the same deal. So why would we have to have an m plus 1 and an m minus 2? Because if I fill in a -1, I get 0. If I fill in a 2, I get 0, right? And then you can put anything you want on the top that's a polynomial of some sort. So I could just put a 1. Done. I have a rational expression that has those MPVs. Or I could go m squared plus 3m minus 4, right? I can make it more advanced or not. The key thing here is that I needed to have non-permissible values of -1 and 2, and I already have that. So I have to add something to the top so that it's irrational. Okay? If you flip over to the next page, that's where your homework is. And I need you to work on it. Rationals is one of those units that if you don't practice, it doesn't get better, and if you practice it, it's not too hard at all. Because seriously, the hardest part of simplifying rationals is being able to factor. So if you can't factor, like I've said thousands and thousands and thousands of times, this unit is impossible. Because if you can't factor, you won't be able to factor the top, you won't be able to cancel anything, you won't be able to state non-permissible values, you won't be able to do anything, actually. You'll just sit and look at the original equation, which is not helpful. Okay? So you need to know how to factor. If you can't factor, you got to come in and get help.